Dear students, in this video we shall start to discuss sets, relations and functions. First we shall discuss about sets. So first we shall see the definition of set. So though we have studied about set in the lower classes, here we are going to understand more concept in sets in deeper. So first of all, what is the definition for set? So we know that it is a collection of well-defined objects. Set is a collection of well-defined objects. So from this definition, what we understand? To form a set, we have to collect some objects or elements. And how to collect the elements or objects? We need a definition, and it is a well or correct definition or clear definition. So having a clear definition, we can collect some objects or elements, and this collection is called set. Here I give some examples. I say collection of beautiful flowers. So you have to collect the names of beautiful flowers. It is not a set because the definition is not clear. So how can you say a flower is beautiful or not? No doubt all flowers are beautiful, and some persons don't like some flowers and they like other flowers. So it depends on the person. So the flower is beautiful or not. Some person likes some flowers and other persons they don't like, they don't say they are beautiful. So the definition is not clear. So we need a clear definition. So based on that clear definition only, we can collect the elements. So to collect the objects or elements, the definition should be clear, or the condition should be crystal clear. Then only we can collect the elements. So to collect the elements, we need clear definition. Clear or correct definition is required. To form a set. Days of the week of the week. So if this is the definition, can you say the definition is clear? Yes. Days of the week is a clear definition or the correct definition. So here we know the elements or the objects coming under this definition. So what are the days we have in a week? Sunday to Saturday. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. So the collection of elements is written in a bracket called set bracket. So I represent this set by some letters, say here A. So I had a definition, days of the week, or I had a condition to collect the elements. The elements should be the days of the week. Now using this condition or definition, I am collecting some elements, namely 7 elements, and no other elements can come under this condition or definition. So I have collected all the elements coming under this definition. So I can say this collection is a set. Okay, another example. months of the year. So this is the definition. So months in a year. So this definition is also clear or correct. So we can able to find all the elements coming under this definition. Let us represent this set by the letter B. So what are the elements coming under this definition? January, February, March, April, May, June, July, August, September, October, November and December. So these are the elements coming under this definition, and no other element can come under this definition, and no element has left, which is not missing. So all the elements have been collected and written in the set bracket. So I can say this is a set. So when the definition is clear like these two, the collection of elements under this definition can be called set. So now I think you are clear about set. So we need a correct definition or condition, and all the elements obeying or satisfying this condition or definition are collected, and this collection is called set. Now let us see some mathematical sets and their representation. Set of natural numbers. So here the definition or condition is natural numbers. So this set is represented as n in caps. The elements are 1, 2, 3, 4, etc. So it has infinite number of elements. The first number is 1 and then it goes on. 1, 2, 3, 4, it goes on. So it is an infinite set. Then set of whole numbers. It is represented as W. 0, 1, 2, 3, 4, etc. So this starts from 0. So which is called set of whole numbers. So the definition is whole number. So whole number starts from 0 and goes on 0, 1, 2, 3, 4, etc. And once again this is also an infinite set. The first two sets what we discussed, namely days of the week and months of the year, are finite sets because they have fixed number of elements. When the number of elements in a set are countable, then we can call it finite set. When the number of elements in a set is infinite, then it is called infinite set. So here we also note the definitions for finite and infinite set. A set with finite number of elements or countable elements is called finite set. Then infinite set. So we shall discuss many examples for finite and infinite set later. A set with infinite number of elements. A set with infinite number of elements can be called infinite set. So set of natural numbers, set of natural numbers, whole numbers, these are all examples for infinite set. Next, set of integers. So it is represented as Z in caps. This contains the elements 0, plus or minus 1, plus or minus 2, plus or minus 3. So this contains all positive and negative whole numbers with 0. So once again, this is also an infinite set. Next, set of rational numbers. So this set is represented by the letter Q in caps. So this is collection of all the numbers which are in the form A by B. So in fraction. So any whole number can also be considered in fraction. For example, 5 is nothing but 5 by 1. So any number which you can written in the form A by B is called a rational number. And what about these numbers? The A and B are taken from integers. A comma B, this symbol is called belongs to A and B belong to Z, which means the numerical values for A and B are taken from Z such that the B should not be equal to 0. So here we have two conditions for A and B. A and B are taken from integers, and the B should not be equal to 0. So these are the two conditions for the A and B. Then set of real numbers. So the definition is real number. So it is represented as R in caps. So this is equal to any number in between minus infinite to plus infinite, x. So the number in set R is x, and what about this x? X is all the numbers in between minus infinite to plus infinite. So this include all rational numbers, integers, whole numbers, natural numbers, everything, but not complex numbers. So all the collection of all the numbers, namely whole numbers, natural numbers, integers, rational numbers, is called real numbers. So one more set of complex numbers. So the definition is complex numbers. Some students may not know about complex numbers. So here you don't worry. The complex number is represented by the letter C in caps. The general formula for complex number is A plus IB. Again, the A and B are taken from Z. Any number which is taken from Z. Okay. And what is this I? This complex number has two parts, real and imaginary parts. This A is called real part, and this B is called imaginary part. I say how these numbers arise. So let us consider the quadratic equation x square minus 4x plus 13 is equal to 0. So this is the quadratic equation, and before arriving the roots of this equation, I tell you what is I. I is nothing but square root of minus 1. If you square on both sides, it will become I square. If you square the square root, the root will be removed. You will have minus 1. So what is I cube? I into I square. I cube can be written I into I square. So I into minus 1, because I square value is minus 1, minus I. That is I power 4 I square into I square minus 1 into minus 1, which is equal to 1. What is I power 71? So if the power is greater than 4, you divide by 4. So what will you get? So you look at the remainder, and that is equal to the power of I power 3. So we know what is I power 3, minus I. Okay, we have to remember this. Okay, now what is the general formula to get the roots of a quadratic equation? Ax square plus bx plus c is equal to 0. X is equal to minus b plus or minus root over b square minus 4ac by 2a. You recall this formula. In the given expression, the quotient of x square is 1. So a is 1 and the quotient of x is minus 4. So b is minus 4 and the constant is 13. So c is equal to 13. Therefore x is equal to minus, what is b? Minus 4 plus or minus root over b square. If you square minus 4, so write minus 4 square minus 4 into 1 into 13 whole divided by 2 into 1. So minus of minus plus, plus 4 plus or minus, minus into minus plus 4 into 4, 16. 4 into 1, 4, 4 into 13, 52. By 2 into 1, 2. So 4 plus or minus 16 minus 52 minus 36. So by 2. 4 plus or minus, when you have negative sign in the square root, you have to write I. So I root 36 by 2. So x is equal to 4 plus or minus root of 36, 6. I 6 by 2. Here I can take 2 as common factor. So 2 plus or minus 3i by 2. 2 cancel. So the roots are 2 plus 3i. 2 plus or minus 3i. So I can say 2 plus 3i and 2 minus 3i are the roots of the quadratic equation x square minus 4x plus 13. So here we can see the roots have two parts, real part and imaginary part. Real part is 2 and the coefficient of I is called imaginary part, which is 3 here. So such numbers are called complex numbers. You also remember that all real numbers are complex numbers. For example, 5, this can be written as 5 plus 0i. So at present it is just enough to know how these complex numbers arise. So which is real part and which is imaginary part. So these are all the common sets which we use in mathematics. Now knowing these sets in mathematics, we shall see some fundamental set operations and their notations. So I take a set A having the elements 1, 2, 3, 4, 5. So it is a finite set or an infinite set? Yes, finite set, because it contains finite number of elements. Now whether the element 4 is present in this set or 4 is an element of this set, yes. So this I can say 4 belongs to A. This is pronounced belongs to. So 4 belongs to A, which means 4 is in A. Can I say 6 is in A? No. The element 6 is not in set A, so I have to say 6 does not belong to A. 1 belongs to A, yes. 1 is in A. So you should know meaning for the symbol belongs to, which means that element is present in the set considered. Next, let us discuss the set notations in two methods. The first one is tabular form or roster notation. Tabular form, which is also known as roster notation. So all the examples which we had discussed for the set of natural numbers, set of whole numbers, set of integers are the examples for roster notations. So here we enumerate all the elements. So set of natural numbers n, 1, 2, 3, etc. Set of whole numbers 0, 1, 2, 3, 4. So I show all the elements in this set. Such a notation is called a tabular form or roster notation. Suppose A is a set having first 10 elements of natural numbers. So A is a set having first 10 elements of natural numbers. So we have understood. So what are the first 10 elements in the natural numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is the roster notation of set A. Then another notation is rule method or set builder notation. The rule method or set builder notation. So I give some examples. A is equal to set where the element x is such that x is a natural number, x is a multiple of 3. X is a multiple of 3 but less than and less than 30. So what are the elements we can collect? So this is set builder notation. If the same we write in the previous method, namely roster notation, what are the elements? And let us assume that these elements are taken from natural numbers. So what are the multiples of 3? 3, 6, 9, 12, 15, 18, 21, 24 and 27, less than 30 only. So this is the roster notation of this set. So here the condition is given for the elements coming in this set. One more example. P set of elements such that x is such that you can also use slash x is an even integer which is less than 30. So what do you understand from this? You have to write even integers, and these you have to write the even integers up to 28 because the numbers the even integer is less than 30. So 2 4 8 2 4 6 8 10 etc. up to 28 you have to write the elements, and this is called set builder notation. So this is called a descriptive method. Next, singleton set. If there is only one element in a set, then it is called singleton set, or a set which has only one element is called a singleton set. A set having only one element, or a set which contains only one element, is called singleton set. For example, set A which has the element only 3, so it is a singleton set. A set of even prime numbers. So first of all, you should know what is meant by a prime number. A number which is divisible by itself and 1. So this is called prime number. A number which is divisible by itself and 1. You remember that a prime number cannot be written as the product of two other numbers, and it should be always greater than 1. So the prime numbers are 2, 3, 4 is not a prime number, it can be written as 2 into 2, so product of two numbers. 5, 7, 11, 13, 17, 19, so etc. So this is the collection of prime numbers. Now the question is set of even prime numbers. No doubt there is only one even prime number. If you write any even number other than 2, it will be a multiple of 2, or it can be written as product of 2 and any other number. For example, 12, it can be written as 2 into 6 or 4 into 3. So it can be written as product of two numbers. So it is not a prime number. So there is only one even prime number. So a set of even prime number contains only one number. So it is a singleton set. So B has only one element, that is 2. So it is an example for singleton set. Next, empty set or null set. So it is a set which contains no element. So a set which contains no element is called empty set or null set. It is represented as phi. Of this empty set. So let us stop this class here. We'll go through all the points which we discussed. Let us discuss the further set operations and notations in the next classes. Dear viewers, இந்த வீடியோ உங்களுக்கு பிடிச்சிருந்துச்சுன்னா லைக் பண்ணுங்க, உங்க ஃப்ரெண்ட்ஸ்க்கு ஷேர் பண்ணுங்க, மறக்காம சப்ஸ்கிரைப் பண்ணுங்க. Thank you.